Okay, so acids and bases. Now, from examining a lot of papers and stuff like that, acids and bases at this point should not be an issue with for you as much. The only issue should be buffers. Am I correct on that? Everyone just thinks buffers the issue. So I have put some easier ones in that are like 4 marks, but I'm mainly going to preface, I know it's called acids and bases, but this session is just basically buffers, okay? So we are really, really close to the exam, so I kind of want you to kind of do the questions with me and get your calculator out, and we'll be doing it together because I think that's the best way to teach you guys instead of just telling you. Okay, so let's get started. So I'm very regimented as a person. I have to have a step-by-step process when I do acids and bases. So I always think when I read a question, what am I actually dealing with? So I kind of have a flow chart. If it's a strong acid, you need to use these equations. If it's a strong base that they're asking you, you need to use Kw. Any weak acid, you use Ka. That's kind of what you need to think in your head and match it. So when you're reading the question, that's what you're looking out for. Is it a strong acid, strong base, weak acid, or a buffer? We'll get onto buffers in a sec. So we'll start off nice and easy, but the next question is going to be buffer. Now, these questions are both OCR and AQA mixed, but they're both pretty much the same in terms of line of questioning because it's just maths. Right, so first one, I'm going to go through it, put the answer in the chat when you're ready because you might find these quite easy. So again, I like to read it. I've got sodium hydroxide, NOH is a strong base, so I'm going to use Kw. And then calculate the pH of 0.14 moles per decimeter of NaOH at 298 Kelvin. Now, because it's Kw, like because it's a strong base, I think obviously Kw. Now, they will give you a temperature. Now, whenever you see something that is 298 Kelvin or 25 degrees, what can I presume about my Kw? Yeah, 1 times 10 to the power minus 14. That's what you need to see. So that's your little clues. Now that you've got everything that you need to know, so to find pH, we need to know H+. We know the concentration of our OH minus, and we know a Kw. So I'm going to rearrange this formula so I can get H+. So I'm going to do 1 times 10 to the power minus 14, which is my Kw, over 0.140. You get your Kw as 7.14 times 10 to the power minus 14, and do the minus log to the base 10 of that. Should get your answer. Okay, perfect. So yeah, you get 13.15. Happy with that? Cool, well done. Everyone pretty much got it right in the chat. Good, well done. Now let's go on to a buffer. So we've got nitrous acid, HNO2 is a weak Bronsted-Lowry acid with a pKa value of 3.34 at room temperature. I like to do things as I'm reading them because that's just the easiest way for me. Like I know the pKa value, I'm just going to turn it into a Ka off the bat because I think that's easier for me. So I'm going to switch that into a Ka. So you do 10 to the power minus 3.34, and you should get 4.57 times 10 to the power minus 4 for your Ka. That's done. Right, then I've got HNO2 can be prepared by reacting N2O3 with water, and HNO2 is the only product. We've got step 1 and 2. They've weighed a sample of N2O3. The water is added to form 100 centimeters cubed of 0.5 of HNO2. Again, I like to tackle it as a head-on. So I'm going to just get my moles of HNO2. So I'm going to do 0.5 times by 100 over 1,000. So getting 0.05, which is my moles for HNO2. Because if you do it this way, you've already pretty much got into a threshold of like 2 marks. okay? Then you've got the chemist adds 100 centimeters cubed of 0.15 of NaOH. So I'm going to do the same thing there as well. So 100 over 1,000 times by 0.15. That's what we get. I'm getting 0.015. Okay, that part's pretty much sorted. I also want to write an equation of what is basically going on. So we've basically got they said we need to explain why a buffer solution forms in step 2. So I'm going to deal with step 2. So they've basically told us that HNO2 and NaOH have added. So I'm going to write an equation for that. Whenever you have buffers, write an equation, especially if you see a 6 marker. It will help you get a lot of the marks. And also, if they ask you reasoning in terms of a buffer, write your equation. So you've got HNO2 plus NaOH. It's a salt, so we make NaNO2 plus H2O. Okay. Now the definition of a buffer is that your acid needs to be the partial neutralization of an acid. Is everyone happy with that? Or your acid needs to be in excess. That's what the definition is. So HNO2 is in excess / partially neutralized and contains A- ions, NO2 minus. That is your definition. Is everyone happy with that? So we've explained why a buffer solution is formed. That is even a 1 marker, your definition of what you need to write word for word. So we've done that part. We need to actually determine the pH of the buffer. So we basically started off with 0.05 mole of HNO2, and then we've got 0.015. What is the ratio in the equation that we're dealing with? We don't know it's in excess. We're going to prove it now, but that's just the general definition. 1 to 1 to 1, okay? 1 to 1, okay? So we look at the smallest one. So we look at the smallest here, which is 0.015, and you have 0.05. So do you see how your acid is in excess there? Yeah, is everyone happy that your acid is in excess? Because you've only got a 1 to 1 to 1 ratio. So only this much is going to react. So we need to actually see how much of the acid is left when we've worked it out. So what I'm going to do is I'm going to subtract them to see how much of my acid is actually remaining. So 0.05 minus 0.015. So we get, if we subtract them, (0.035 remaining when the buffer solution has reacted. Okay, let me have a look at the chart. So it's a buffer, right? It's not going to go through full neutralization because it's resisting the changes of what you add. So neutralization, we think H plus OH minus gives you H2O, right? But then you've also got a salt there, so it's not going to fully neutralize. It's getting basically counteracted at the same time. That's what we mean by partial neutralization. Is everyone okay with that? You can say either or. You can say either if it's excess or partial neutralization. So just say excess if the partial neutralization is confusing you. Right. So we've subtracted them, we've dealt with it. So we have basically found out what is remaining. Now we need to find out A minus. Now it's all a 1 to 1 ratio, okay? So again, our NO2 minus ions are basically going to be 0.015 because it's all a 1 to 1 to 1 ratio. So now we found all of our moles, we can evidently just put it in the equation that we need. So I want to find what H plus is because I need to get a pH. I also already know my Ka because I worked it out at the start. So I'm going to do 4.57 times 10 to the power minus 4 times by, you do HA over your A minus, okay? That's how it typically is when you rearrange it. So we do 0.035 over 0.015, and you should get your H plus, okay? You can see if you can skip ahead and get your pH, guys. Okay, so I get 2.97. That's the answer. Right, have a look. Is anyone confused? Put your thumbs down if you're confused. No. Everything's, you don't need to work out the total volume because everything's in a 1:1:1 ratio. So you don't have to really touch it. When you have issues when everything's not in a 1:1 ratio, which we'll see in a few questions. It's preference. So with your formulas, it's preference. For me, I like using moles. Some people like using concentration. Some people like using Henderson-Hasselbalch. In the equation, in the exams mark scheme, it has alternative working outs for all of three of them. So do what you want. Because it's a 1:1 ratio, right? That's your moles for your NO2 minus technically, isn't it? So that's how we know it, because we know it's a 1:1 ratio when we write the equation. Why is NO2 the limiting factor? HNO2 the limiting factor? I always use this one. So that's how you know which formula to use, because you know that you've got a HA, which is your weak acid. Your A minus is mainly your salt. And then you've got a Ka. So that's how you know which formula you do. Why is HNO2 the limit? You look at the molar quantities. That's how you check. They're completely different. So you're assessing whether or not something's the limiting factor by looking at your equation. If it's all 1:1:1, you know that each one of the moles is worth that. This is way too high, so that's why we're subtracting it. Could we go over the Ka equation? Any other questions? Yeah? Right. So the next part of the question is saying we need to calculate the mass of N2O3 and HNO2. Well, they basically said that N2O3 it reacts with water to give you HNO2. As the only product, okay? So if we balance it, what do I need? If you rearrange the equation is nothing new that you haven't seen. It is literally the same what you learn in weak acids. H plus A minus over HA. That's what you're rearranging. Okay? So it's just a weak acid because it's a weak acid buffer, right? So you can use Ka. TA, yes? Do you want me to, are you okay? Okay. Are you okay with it now that you just rearrange this for H plus? Okay, cool. Right. I'm gonna move on to the next part. So to balance this, we've got two lots of NO2 and O3. So that means we need to put a 2 on this side. Yeah? Everyone happy with that equation there? There. Right? So we've got a 1:2 ratio between NO2 to HNO2. We've got a 1:2 ratio, okay? So if we know the moles of HNO2, right, then we know that we can basically divide it by 2 to get the moles of N2O3, okay? So we had 0.05 divided by 2. That will give us the moles for N2O3, okay? So that is basically 0.025. Now, if I need a mass, and I've got moles, what do I work out? MR, right? So you got N2O3, you work out the MR of that, okay? So we've got 214 plus 14 plus 16 plus 16. 76, okay? So we can do the moles times by 76, and we can get our answer as 1.9 grams. So we've got this part here. Everyone okay with that one? That one's not too bad. It's a mess, but again, it's 6 marks. So that's why it's this bad. Right, let's have a breather. We're going to do a KW one. So again, KW equals H plus OH minus. Right. You can, when you do, like, there's not enough information here, right? That's why students get upset. Okay. So they're asking at 40 degrees and they want a pH. Now, we don't know what sort of answers that we only have a KW, right? Oh, the answer is 1.9 grams. There. And your pH is 2.97. Right, so we know that 40 degrees means that we're going to be using this KW. Right, another way that you could, the reason with KW, you can manipulate the equation now because your concentration of your H plus to OH minus can be the same, to which they cancel out. So you know the way that we also presume in the Ka equation how the concentration of H plus and the concentration of HA are equal to each other, and therefore we can get the Ka equals H plus squared over HA. Is everyone happy with that, how it cancelled? You can do the same thing, but with KW because the concentrations are the same. So if you don't have a lot of information and you're freaking out because like, where's my OH minus, you can rewrite your equation as KW is H plus squared. So we know our KW is 2.92 times 10 to the power minus 14. And if we want to know what H plus is, you can just square root it. And that will give you the H plus, and then you can get a pH. So when you guys are ready, put your pH in the chat. So you should get 6.77 as your answer. Cool. And then you minus log to the base 10 that. The reason why, do you see how it's a 1-to-1 ratio? In the neutralization equation, you've got the same amount of concentration for H plus and OH minus, so therefore they cancel out. So because they cancel out, you can basically rewrite it to say that you have 2 lots of H plus, and that's why we can square it. It's just an assumption that can be made. They use the same assumption in Ka. Is that okay? Cool. Right, next one. So a student reacts strontium metal with water to make 250 centimeters cubed solution of aqueous strontium hydroxide. The solution contains 0.15 grams of strontium hydroxide. We need to write an equation with water, and then we need to calculate the pH of the solution and then use the table. So this question is 5 marks. I would get like my equation out the way. So to make strontium hydroxide, we need strontium plus water gives you strontium OH2. And then because strontium is a metal, we have hydrogen. So we've got too many H's on this side, so I'm going to add a 2 in front of my H2O. That's the equation done. Right, so let's have a look at what we've got in the question. We've got a volume and we've also got a mass. Technically also have an MR. So I'd go straight in and work out my moles for strontium hydroxide. Which is 0.145. The MR, oh, I need to work out a periodic table. $88. I think 16. Yeah, cool. So I'm getting 121.6, yeah? Okay, so we get our moles. As 1.1924 times 10 to the power minus 3. That part's done. So you're dealing with kW. I always have like, I'll put it on YouTube. I'll put my link to my YouTube in the comments at the end so you can find it. Right, so in kWs, do we want moles or what? What do we prefer things to be in? Concentrations, right? And you've got like something that has got OHs, so we can do the concentration of OH minus. Now, because you've got the moles, but then you've also got a volume at the top. Now it's OH2, so what do I also need to do to my answer? Times by 2, because you've got 2 lots, okay? It's just 2 amounts of the concentrate, 2 lots of OH, okay? That's what you need to think of. So I'm going to do 2 times by 1.924 times by 10 to the power of minus 3 divided by, I'm going to do divided by 250 divided by 1,000. So whatever that is, and should get my answer for my concentration. I think this should be 0.25 basically. Okay, you get 9.539 times 10 to the power minus 3. Yeah, that's done. They said, look at your table. You got KW. We've got our OH minus. We can square. So does H plus equal O? We don't need to square though in this because we've got our OH minus value, haven't we? You only square if you don't have any other information. Like in here, we had only a KW. That's why we squared. But in this case, we don't need to, okay? Because we've got an OH minus. Is it times 2 because of the ratio then? It's times by 2 because of this. You've got 2 lots of OH. That's why you have to times it. Because you're saying you've got 2 lots of OH. Okay? So that's what you get. Now we've got a KW. We can work out what H plus is. Everyone's already ahead of the game. So you do H plus equals KW over OH. So we get 2.92 times 10 to the power minus 14 over 9.539 times 10 to the power minus 3. And we should get boiling 3.061 times 10 to the power minus 12. And then log it. Should get 11.51. Cool with that one. That's the most long-winded 5 mark I've seen come up in terms of this. Okay, buffer. I'm not going to do the mono basic one, okay? I'm just going to get straight to the buffer. So we've got a buffer solution is prepared by dissolving 3.39 grams of potassium hydroxide. Off the bat already there, that's my little indicator to say, you know what, I can get moles from that. Then I've got 250 centimeters cubed of 0.376 of butanoic acid. So that's also my little gateway. Get those marks out. They're easy marks. At least you can get one. Will this method work every time? Which method? What I'm doing right now? Or the one the previous questions are? Oh, yeah. yeah, it's never going to change. You have to have a KW, you have to have an OH. You always will have to do this. It won't be strontium, but I've seen barium hydroxide, and they like to put hydroxides in because that's little ways to throw people off. So yeah, I would probably stick with that. Right, so then we've also got the pH. That's we can get H plus from that. And then they also want our Ka. So technically, do you see how we have technically an A minus, a HA, and a H plus? So do you see how we can use these values to then get a Ka? Is everyone happy with that? Cool. So try and fill up those little checkpoints. Like literally, if you get confused, write this on the side and see, you need to have 3 of them, right? And tick which ones, and then that will help you, okay? If you really hate buffers. Right, so let's get working to moles. So I'm going to work out my H plus first. That's my easiest. So I'm going to do 10 to the power of minus 5.07 is 8.51 times 10 to the power of minus 6. Then I'm going to do I'm putting it as A minus, but you can also just put it as OH as well, whatever you want. But you need to just know that's your negative. So we've got 3.39 grams potassium hydroxide. I think it's like 39 potassium, isn't it? Yeah, so we've got 56.1. That's also going to give us our moles. The reason why you're putting it as your A minus as well is because it mimics the conjugate. So that's why I like to put it as A minus. So 0.0604. Everyone happy with that so far? Easy peasy, cool. Okay, so now we've got the HA. So with HA, I'm going to do concentration times by volume to get my moles. Zero point 0.094. Right. How do we know this is a buffer? Remember the definition I gave you? It's the MR for KOH. Okay. How do I know this is a buffer? Look at your molar quantities. What is going on? Are they the same? What's going on? Excess, exactly. So your acid is in excess. So if it's in excess, what do I need to do? Exactly, there you go. Excellent. So I'm going to subtract, okay? So I'm going to find out how much HA is actually reacted and in the buffer. So we're going to do 0.094 minus 0.0604. We get 0.0336 left over. Now you've got everything that you need to know. We can shove it in our equation. Now we want to work out Ka, right? So we can basically do H plus A minus over HA, like you normally would find it. What did we just subtract? This one minus this one, because this is in excess. Yeah? Okay, so sub your values in. Get me the Ka actually. So you guys are what you can put in. You need to use this one for your HA now because that's whatever's remaining. So if we get at 8.51 times 10 to the power minus 6, A minus is 0.0604 over 0.0336. You don't need to divide by the volume because you guys are getting confused. You can do mole buffers with moles, or you can do buffers with concentrations. You divide by the volume if you want to do concentrations. The reason why we don't have to do volume and we can use moles is because everything has the same volume, doesn't it? Overall, the buffer has the same volume. So when you put it in, it's gonna cancel out anyway. All your volumes will cancel out when you cross them out and work it out. That's why you can get away with using moles. If your buffer if you have different volumes for your buffer, then I would recommend using concentrations. Does that make sense why you can use moles over concentrations? And it's in a different volume. The buffer is in the right volume, because this one and this one is a different value. Your smallest one is going to be a 1-to-1 ratio. You can write your equation out if it helps you. But it should be in a 1-to-1 ratio. That's how we know it's in excess, because only this much should react. And that's why we're figuring out how much actually is left when the reaction occurs, which is that. Okay? So when you work it out, you should get your K at A as 1.53 times 10 to the power minus 5. Yeah? Let's say you did concentrations, okay? If you did concentrations, if we did concentrations, let me figure out what we'd get. We've got moles, so did you divided by? If you did concentrations, you should get the same value. Yeah, that's final answer. If you did concentrations, you get the same answer. The reason why I have kept it in moles and not concentrations is this and this are in the same volume, so they would cancel out. That's why I kept it as the way it is. Even if you did concentrations, you just get the same value anyway. They just cancel out. Does that make sense to everyone? Okay, so everyone's like freaking out in the chat. Cool, I'm gonna move on. Thumbs up to move on. Yeah, cool. Right. This one is I'm looking at the time. Is everyone okay to skip this one to do a neutralization curve? Yeah? Because I think you'll be fine with this one. Okay, let's do about neutralization curves. So I've only ever seen one neutralization curve in OCR and one neutralization curve in AQA. So I'm going to do both with you to look at, because they're both a bit weird and so in different ways. So this is the OCR one. We're going to do the AQA one in a sec. I've heard on the grapevine that it may come up this year. Okay, so just listen and then it's not too bad. Right. So with a neutralization curve, you draw your line of best fit. So just try and draw as best as you can, like that, how you typically see it presented. So do you see how they've done it in the AQA one, how they've drawn through it? That's kind of what you're aiming through. So that's what you mean. They said, so we've drawn the line of best fit, and then we need to calculate the concentration of CH3COOH. So we've got a pH, and we know the volume of barium hydroxide. They've also given us an equation. I don't know if you're in my boot camp, anyone, but when you see an equation, what does that indicate? That you're going to be using what? You need to look at what? Ratios. Fantastic. Well done, boot camp, guys. Yeah, so you got ratios. So we know that even though they're asking CHCO3 and they're asking about barium hydroxide, we need to find the moles of barium hydroxide, and then we'd probably have to divide it by times it by 2 sorry, to get the to get the answer. Is everyone happy with that? Using the equation and going from there. So how would you actually use the curve? So what they expect is a smooth S-shaped curve using a line of best fit. The reason why they don't say just draw a curve is because they don't expect you to get it spot on, but try and go through a majority of your points. That's what a best curve is. If it's a straight line curve, I always say if it's like 4 crosses, go through at least 3/4 of them. That's what they want on. So do you see how I've like missed a few there? They won't care as long as it majority goes through most of the points. Now, you need to look at your neutralization curve and read off where the equivalence point is. So if we read down from the equivalence point, which is here. Oh, I'm going to be a bit off because I'm on an iPad. I'm going to say it's 12.5, okay? Straight line for the vertical section, is it only first one? The equivalence point is this, where it goes straight. That's your equivalence point, yeah? We call this equivalence point, and this here is your equivalence volume. Yeah? Do you know how to draw a straight line from the vertical section? Or is that only for strong acid? You don't, as long as you need to just mimic the curve. So you don't think about it too deep. Just mimic the curve like the way they've done here. They just want a nice, smooth S-curve drawing. Is that okay, Sharon? Okay. So I'm going to read off the point for my volume to be 12.5. Okay. If you read the question, we've also got the concentration here as 0.0560, okay? So we've got a volume and we've also got a concentration. So I can get my moles for barium hydroxide, okay? Now, you may think, oh, it's barium hydroxide, so you have to times it by 2. No, we don't need to do that because we're not looking at concentration of OH minus. We just want moles. So just like deal with it normal. 0.056 equals, let me see what you get. Get 7 times 10 to the power of -4, okay? So to get the moles for CH3COOH in the equation, I'm going to do 2 times that. It just tells you the volume at which the neutralizations occurred. So this is basically saying this is where you've got kind of equal parts going on. That's what it's just telling you, where it's equivalent. Or your OH and your HS is there. That's all it tells you. Is that okay, Zara? It's just a titration. So you know in your titration, you have like where the color change happens. That is basically what the equivalence is. And then you put your pH probe in and that's it. This is the easiest point to read off. They're titrating, so you want that equivalence point. Every other point on the graph you don't need. You always base it off on a titration curve. The only thing that they care about, and that's a actual value, is the equivalence point. That is the pH of where the colors changed, right? Everything after that has got no other factors included. Is that okay? It's like your stagnant point. That's why we use that point. Is that okay? So it's just a good metric point. Why would you read off here? Because you want an equal point, and that's generally your equal point. So I'm going to 2 times my moles to get that. So it's 1.4 times 10 to the power -3 if we double that. So if we want concentration, do you see here we've got a volume here, 10 centimeters cubed. So to get my concentration, I'm going to do 10 over 1,000, and then we can also divide it, and then we've also by our moles, sorry. N equals C times by V. So we've got a concentration, which we don't know, and then my N is going to be 1.4 times 10 to the power -3 over 10 over 1,000. So you should get your concentration as what? What do you guys think? Yeah, that's it. 0.14. Done. Is everyone okay with that? You have to look at the equivalence point. It's your stagnant point. Don't read off anywhere else. That's what they care about. Right, should we do the AQA one? Right. AQA one is asking you for KA. It's not bad. It's just like there's certain things that you got to know. Now with this one, you need to know something else about the equivalence point, okay? So with the equivalence point, you need to know that, what does anyone know the specific point you need to know? Anyone? Right, remember this. We get pH equals pKa at what? At half the equivalence point. Well done. That's what you need to remember. pH equals pKa at half the equivalence. Because that basically means, doesn't it, that H plus is equal to Ka at half the equivalence, right? Is everyone happy with that? So that's your root. You need to kind of think, okay, how can I get Ka? You can get Ka from pKa. I would say it's worth knowing because they haven't asked it a lot, and I think this could possibly come up. They could ask you Ka. So I'd say it's something that is worth remembering. It's only a little line. So just think half the equivalence point is normally what pH equals pKa. So it's maybe write it down on a flashcard because I don't know what they're capable of. Does that make sense? They could ask anything because it hasn't asked that much. Okay, right. So we need to determine the volume at half the equivalence point, okay, for propanoic acid. So if we look at the equivalence point, I'm going to read down. Getting like 19.5. I'm just reading, obviously read off properly. And we want half the equivalence point. And we need a volume, right? So yeah, so we need a volume. So I'm going to do half of the equivalence point and divide it by 2. I don't know if that's the top of my head. 9.75. Everyone happy? Why I've done that? Half the equivalence point, whatever. Now, you can get your pH now, because if you look for 9.75 off here, it's round about there. You can read up to get your pH like that. Oh, do it better than me, obviously. But we're going to say like 4.8 is our pH. So remember, your pH is equal to the pKa of half the equivalence point. So technically, you can get your Ka by doing, this is your pKa technically. What can I do to that to get my Ka? Yeah, 10 to the power of minus 4.8, you get your answer. And that is 3 marks. 1.58 times 10 to the power minus 5. They'll give you like a leeway as well, so don't stress. But is everyone okay with that? Those are the 2 things that is pretty much titration curves. We want half the equivalence point. That's why I divided it by 2. Okay? So if you look for the equivalence point, read down, do half of it. That's how you get the half. Read up, get your pH. Then you know that pH is equal to pKa, so you can get your Ka. Is that okay, Aisha? Oh, let's go. Right. Now we're hitting AQA questions, but again, OCR, they're buffer questions, so you can use them if you run out. Let's have a look. So this one's a bit trickier because I wanted to put a harder one in when you have to add and subtract, and let's talk about a bit why. So you've got a student prepared a buffer solution by adding 0.0136 mole of salt to 100 centimeters cubed of 0.5 solution of weak acid and mixing thoroughly. The student then added 3.0 times by 10 to the power minus 5 of potassium hydroxide. We need to find the pH. We've got a Ka. Okay. Looking what we have a Ka. We technically have an A minus, we have a HA, we need H plus. That's kind of my line of thinking. So I need to get values for everything. So I'm gonna get my expression out of the way, and because they're using weird metrics like HX and KX, and I want to get that out the way. Now, HX is my weak acid. So if I do my Ka equation, you're basically getting H plus X minus over HX. Yeah? That's all right with that, okay? We want H plus, so I'm going to rearrange it. And we use Ka times by H. We want to use H plus equals Ka over HA over X minus. That's basically what's going on. So instead of using A minus, we're using X minus, yeah? Everyone happy with that? Basically the same as we did before, but I'm using the metrics, yeah? Cool, right. So we've got the moles already, and then we've also got this for the weak acid. And then they've also given us potassium hydroxide. So basically they're saying potassium hydroxide is reacted with the weak acid, okay? So if I wrote an equation, we've technically got HX plus, I'm just going to put OH minus for the potassium hydroxide, is going to give you your conjugate X minus plus H2O, because it's acid plus base gives you salt plus water, yeah? So when you have a buffer, when you add OH minus, what will it generally react with? Looking at this equation. Acid, because it likes to fulfill neutralization, the neutralization equation, right? That's basically what we wrote. Now, the whole idea is that because you're adding OH minus, it basically uses up acid, but it also makes more salt. Because it's using the acid, let's say we had this, it's using this acid, it's taking it away, so you end up with more of the conjugate left because we ripped the H plus. Everyone happy with that understanding? So if you're using up the acid, you will have to take away, but to make more salt, we need to add. That's where you get the add and subtract from, okay? Right, let's do it now. So we need to work out the amount of HX. Now I'm just going to work out moles for that. So HX equals 100 over 1,000 times by 0.5. I'm getting 0.05 moles. How do you know when to add and subtract, or when just to subtract before? Because in the other questions, when we added, it was just asking, do you see here, like we only had a HNO2 and A minus as a factor. They never really said, okay, we had a buffer and then we're adding something extra to it, if that makes sense. So we only thought, okay, we need to only ever deal with the excess. Here, we know that we've got a salt. We also know that they have basically gone and added extra OH. So that's when I know to add and subtract, because we've had the buffer originally and we're not just dealing with that anymore. We know that they're adding extra stuff to which is causing the resistant changes to which we have to add and subtract. That's how you kind of remember with the wording of the question. Okay, so we've got the moles of HX. Now we need to know about the amount of HX after you add the KOH. So I'm going to basically subtract. So we do 0.05 minus the KOH amount that they added. 3 times by 10 to the power minus 4. So you get 0.0497. Okay, that is HX after KOH added. That's done. Now, KOH is going to basically make a salt. So your salt is X minus, right? But when it adds the KOH, we're going to basically get something that's KX, isn't it? So after we add the KOH, we need to say, oh, we've made more. So we have 0.0136, which is our salt. Oh, plus, I'm writing in highlighter, great. 3 times 10 to the power minus 4. And that should give us 6. Zero point 0.0139. Everyone happy with that? Before we move on. Cool. So we can shove it in now because technically this is our HA and this is our A minus. And then can everyone work out the pH then by shoving it in here? Excellent. Yeah, 4.3. Okay, right. So is it always acid minus base? Yes, because that's the one that you have more of. Acid is always in excess in a buffer, always in excess. That's the definition of a buffer, is acid in excess with conjugate ions at the end, or two at the end, or now. Could you summarize each step, please? Overall, of how to do the buffer of this question. Okay, so write down, you've got an salt plus acid. So we know that there's a buffer. The reason why we're adding and subtracting strong, what if a strong acid was added? So if you added a strong acid, you use up the salt and you end up making more acid, right? So you do, if you're using up the salt, you subtract from the salt and then you get more acid, so you add more to the acid value. Is that okay? So just write this as your little, like, remember, like little, this is a good little step to add on. That's your rule of thumb, when to add and when to subtract. When to minus and then when to add. That's it. So overall, we know it's a buffer. If it's a normal buffer and it asks you to work out pH, you just need to look at your ratio of your actual buffer equation, figure out if it's 1-to-1, and then you can do the whole excess minusing like normal, okay? If the issue is that in here, we've got a normal buffer here, but then they added the extra line to say, oh, we've added OH minus now. That's when you need to know, okay, I need to subtract and add. That's your step-by-step protocol. What assumptions? Which assumptions? These ones? Exactly. So you make more of you use up the conjugate, but you'd make more acid. So then you do opposite of what this would be. Yeah? Yes. I have seen them ask you the assumptions. They like to ask you the assumption that is made with Ka. The assumption for Ka is H plus is equal to A minus. They could ask you Kw, which you need to assume that H plus is equal to OH minus. So yeah, they do ask you assumptions, so I would learn them. Get them on a flashcard, just learn them. And we can only work in moles if it's 1-to-1. It's preference. So if you've got to think when I look at the mark scheme, you can work out a buffer using moles. You can use it with you can work it out with concentrations, or you can use a Henderson-Hasselbalch. So it's not always moles, but it's your preference. Now, some questions, for example, you'll have to use concentration. I think there was one that I wanted to talk about. This one. Right, this one, you can't use moles. You have to use your concentrations because in buffers, your acids and sulfur are both the same amount, so they're going to cancel out. But this one, we don't have any clue about, how do we kind of say? To be honest, you could work it out in moles as well. Ignore me. Ignore me. You don't need to. You can always do it in moles. Just do whatever you're comfortable with. Okay, okay. Is it always buffer strong acid and buffer plus strong acid? Or is there a scenario with weak salt and weak acid? Buffers are not always strong acids though. Buffers are like, buffers you can have a weak acid buffer. A lot of the time they use both butanoic acid. So you know when it's like ethanoic acid and sodium ethanoate, that's like the most common buffer. So they could give you anything, but the whole idea is that you can have a more acidic one with a salt. That's the whole idea. You have a bit of some form of acid with the salt. That's what you need to remember. And that acid will always be HA and that salt will always be A minus. Yeah. Anything else? Is that okay, Zara? Any more questions? All right, overall, was this okay? Did you feel like it was, I don't want to confuse you anymore. Did you find it okay? Okay. Good. I think it was one of the topics I wanted to do as its own hour lesson because it was horrible. It's a horrible topic, but hopefully you get a bit of clarity. What I'll do is I will send an email now with a blast with the questions because we didn't get to do a lot of the questions. So I'll send the answers and everything in like an email so you can have a go at the end ones yourself and look at the answers. And then I will, do you want me to put my YouTube in the chat? So it will be on here. It takes it takes ages to download because it's an hour of footage, but then I will, will they come with your working out? So the video on YouTube, which I'll post tonight, will obviously have all my workings, but the other one will just be the answers from the questions and that. So you can watch it side by side if you want. Yeah, I'm gonna be doing a few more. Like I do a free webinar every now and then. So again, here's my Luma. Just subscribe to my Luma and then you'll get emails whenever I do something. I think probably it's borderline harassment, but I'm just going to stop the recording.